my question. As you multiply matrices from yesterday, what is your way of, hopefully you got into homework and practiced it, what is your way of remembering how we do matrix multiplication? From yesterday, before we even get into like the identity matrix. Row by column, and then what do you do? Multiply, add, multiply, plus, multiply, right? You match up each entry in a row by each entry of a column. You're multiplying them, and then you're adding, similar to what from vectors? Dot products. There we go. It did kind of stick. Similar to dot products. But wait a minute. Once you do the first column and the first row to get the very first number, what do we do next? We have a lot more numbers than that. Move over. Yeah. And then do the same thing, right? And then you get the next one, and then move over. Do the same thing, and then go down to the next row. Do the same thing, right? And then we do the second row, first column, second column, third row, first column, second column, third column. We're multiplying, we're adding, we're putting them together. The cool thing about the identity matrix is whether you go this way or whether you say, hey, it's a 3 and then 0, 0. Oh, the 3 gets to stay. Whichever way you multiply the identity matrix, it's the very first time for us, but also the only time that you can multiply A times B and B times A and have it be the exact same thing. Is with the identity matrix. And it's called the multiplicative identity because, well, if you multiply it, the matrix stays the same. But it's quite weird in that it's not all ones, it's not all zeros. It's a leading diagonal or a main diagonal of ones, and then the rest are zeros. This one, I'm throwing it in the notes just because it's going to be helpful for homework if you guys haven't gotten stuck already. You might get a little stuck when they give you a big old system and they want you to solve using this idea of a singly augmented matrix. Now we've already done the augmented matrix in section 8.1, but I introduced something to you that some of you actually, I think Nathan, you answered with it the next day and you remembered it. But since we hadn't done matrix multiplication, it might not have made much sense. If you guys notice, where did this variable matrix come from? Why are we allowed to take all the coefficients away from the variable and augment it with the constants? It's all because of this symmetry of having all the x1s, all the x2s, all the x3s in the same column. Because what I'm actually doing is I'm factoring out this matrix multiplication. I'm actually factoring out all of this matrix multiplication. In that, the x1, x2, x3 came into row 1, came into row 2, came into row 3, the same way I can pull it out. And when I pull it out, I now have these, or this expression, this equation, which in math, don't we normally solve for x by just dividing both sides by y? Not by y, by the coefficient, by whatever's there. But here's the dilemma. Is there such a thing as matrix division? What do you guys think? Do you still have matrices in your calculator from yesterday? Can you guys try doing A divided by B? Uh-oh, I'm going to come steal any test that I see in the next 30 seconds. I told you to put them away. I'm going to steal them in the next 30 seconds so you don't put them away. Chapter 7, chapter 6, get them put away. I know, it's a bummer. Obedience is the way to go. Do whatever you think is best. I support you. Okay. So we're back in our notes. I want you guys to go ahead and go into your calculator. Can you do B divided by A or A divided by B? We put some different ones in there. You don't even have to use these ones because there are no numbers up here as far as who A is and who B is. I'm just curious. Is matrix division a thing? Yeah. Did you try? Division's not a thing. So here's the sad part. If division isn't a thing, has there been anything this year, any equation that you've seen where we couldn't just divide to get rid of what we didn't want? But that is dividing. I mean, multiply by reciprocal is dividing. 4x equals 2. We can multiply by 1/4 or we can divide by 4. But what's something we saw this year where division didn't get rid of what we didn't want? Why were we bringing in inverses? Or when did we bring in inverses? Trade. If you had tangent of x, question. Were we just allowed to divide by tan? That doesn't work? No, if you tried root 3 in your calculator divided by tan, it means nothing. True? The only way to undo tan is to do tan inverse. What if you have a square root? This is a basic one that everybody should know. I should know because I'm teaching Algebra 1 square roots right now. Can you divide by a square root? 4 divided by a square root. Does that do anything? No. What do you have to do to both sides? Not radical. Already has a radical, but squared, right? So we have to bring in these inverses. We have to do whatever the inverse operation is, and it's not always division. And you guys know it's not always division, because if I had x plus 3, wouldn't you be like, oh, minus 3? You know the inverse to some things, just other things you have to get used to. Ooh, there was one more spot. With trig, yes. With like radicals, yes. What was the other one? Yeah, ln's and e's. How do you undo an ln with an e? How do you undo an e with an ln, right? Okay, so we have all these different inverses that are special. So guess how we're going to get rid of a? Guess how we're going to get to x? If we can't just divide, we're going to figure out what the inverse is. Now wait a minute. What I do to one side, I have to do to the other. But am I allowed to, from what you saw yesterday, am I allowed to do that? No. Why not? What matters? The order matters. So if I'm multiplying A inverse by A to get rid of it, because an inverse always undoes. The squared undoes the square root. The tan inverse undoes the tan. The ln undoes the e. If I undo to get x, which is my objective, where do I have to put the inverse on the other side? Yeah, it's going to be weird, but it's the only legal way to do it. So we're kind of getting you ready for that. That's one of the big things that's coming. And we're going to see that an inverse, what does an inverse do to a matrix? An inverse brings it back to its identity. Oh, wait, what did we just talk about is the identity of a matrix? Oops, too far. I hit it and it goes back 2 pages. This guy. Wait a minute, what have we already learned our calculator can do to get back to this guy? RREF. So we actually have this whole section in our book, guys. It's section 8.3. It's going to teach us about inverses and how to find them, how to use them, what they're good for. But anyway, this page, you can write it. I put a big X through it because you guys already started taking 8.3 notes. It's one of those where this whole inverse idea has its own section that's coming. But what or why I think this is in here right now is because I wanted you to see, hey, if you understand matrix multiplication, maybe you see how we're able to take all these coefficients away. As long as they're nice and ordered as far as by columns, I can pull them out or I can put them in. And that brings us into this word problem. For those of you guys that have done homework, any word problems in homework? No, I was nice. There's one. The reason why I'm giving us a word problem in class is, did anybody remember from yesterday? I prefaced it. We just hadn't gotten there yet. Yeah, to see like how on earth they tie together. Like how do matrices, why would you ever put information in a matrix? If I'm telling you there are all these college classes that have to do with computer programming specifically and engineering and design and all these other places, maybe in business a little bit, but not as much. Why would you ever put information in this rectangular array guide? Why not just put it in equations? Well, we're going to kind of grapple with what these numbers mean, because if you guys notice, is anything labeled in A or B? So we have to figure out in context of the problem what the heck is going on. So I want you guys to go ahead and figure out, that's a little too big of a task. What we want to figure out eventually is, what are the rows, what are the columns of A, what are the rows, what are the columns of B, without them even telling us. So we have to figure out, okay, what the heck? So what's a local dairy mart? Has anybody ever seen one of these? A lot of you have. Does anybody live in Santa Clarita? Like a little drive-through convenience store in Lions, like Anybody been out of California or like in a little small town? Yeah. So Some of those have like little dairy marts. They're probably not even called dairy marts. Milk stores. They're usually called milk stores or dairy stores. It's a thing. It's just not a thing in most of your guys' like your context of where you live right now in LA. Honors was able to come up with some, but I also have some kids in honors that have like visited the South and stuff too. But a local dairy mart, I know it's weird, I know it's awkward. Just think of like a specialized 7-Eleven that's mostly for like eggs and milk, and I mean most dairy marts these days have other convenience items too. But just think of like a 7-Eleven, okay? So 7-Eleven specializes in milk. There you go. The numbers of gallons of skim milk, 2% milk, and whole milk sold over the weekend. Think like a business. What are your days of the weekend? Which three? Yeah, Friday, Saturday, Sunday. If you're a business, you have Friday, Saturday, and Sunday as a weekend, right? Just think of when the movie theater is more expensive. Okay, Friday, Saturday, Sunday. So we have 3 days of the weekend, and we have 3 types of milk. Oh, hey, what kind of matrix do we have? Okay, keep reading. The selling prices in dollars per gallon. Oh, those are money. That makes more sense. And the profits in dollars per gallon for the 3 types of milk sold by the dairy mart are represented by B. From these 2 little blurbs of information, can anybody fill in anything? The rows are columns of A, the rows are columns of B. There's one clue that unlocks the entire thing. The columns are the milk. Not where I would have gone first, but you're possibly right. So this way of thinking, skim 2% and whole. Let's see if that makes sense. I have skim, I have 2%. I'm just writing it. Okay, so if those are milk, what else is going on? So these would be the Friday, Saturday, Sunday. Okay, so what else? Yeah, B was the easier one to plug in, no? Did you guys read his blurb again? Both of them are dollars per gallon. Wait, both. That means 2. Wait, 2. There are only 2. Yeah. So I have the prices. You see it? This is what I thought was the key, because I'm like, well, it's 3 and 3 and 3. Ooh, 2. 2 is prices and profits. Wait, why are the profits so much less than the price? Yeah, right? When people sell things for a certain amount, it's all of that profit. Not unless they stole it. And if they did, there's still like consequences just in a different way. True? Okay. So there's always something they have to pay, or someone they have to pay, or rent that they have to pay for the space that they're selling from, unless they're like on the street with taco stands, which are quite amusing. But coming back, there's always something to pay for. So we have prices, we have profits, so that's going to be more, that's going to be less. That makes sense. Wait, what are my rows? Oh, there we go. So we have our skim. We have our 2%. Now is the time you can go back and see if Sue was right. Because we built that whole first matrix on what Sway said. Now the one down here is for sure. There are only 2. Prices, profits. That has to be the column, so these have to be the types of milks. How do we know whether he's right or not? How do we test it? Oh, maybe we should keep reading the question. Compute A times B. Oh, we're supposed to be multiplying these 2 guys? How do I know Zway's right? If I now realize I'm supposed to be multiplying the 2? How does multiplication work? Skim. How many skim gallons of milk were sold on Friday in the store? 40. Times, ready? What was the price of, what kind of milk does it need to be of? Skim milk, yeah? Oh, okay, so I have skim milk 40 at $3.45, and then 64 at $3.65, and then 52 at $3.85. Does that make sense with each of these milks and their respective prices? yeah, I had to have the 3 milks be in the same order, and I had to have that row be the same label as that column. But now I can do one multiplication if I just plug in my data as far as how many gallons of milk for each day that was sold, and what I know about the prices, what I know about the profits. One quick multiplication. Well, wait a minute. What am I going to get when I do that one quick multiplication? I'm going to be multiplying A times B. A is a 3 by 3. B is going to be 3 by 2. So what size is my answer going to be? Those match. That's good. It's going to be a 3 by 2. But asking for us to interpret the results. You guys could totally do this in your calculator. And when you do, we're just curious, do you know what you've gotten? Let me go full page on you. What have you gotten once you find all of these? Pause, put it in. Let's practice with our calculators. You can use them anyway. It's good for at least half the test, probably 2/3 of the test. I want you to throw in this information. I'm going to go over and throw it in as well. Except I don't think you guys need me to model for you how to do matrix multiplication, so I'm just going to go ahead and do it in my little hand one. It's way easier. As you're getting numbers, look at how big they are and see if you can interpret what's going on and what you're getting at. Yes, you guys know some people's almost entire jobs are data entry.
Do they get paid well?
It's more of a white-collar job, but I'm not sure it requires tons of skill unless you're realizing, wait a minute, how easy is it to need to go fast with numbers and to possibly type something else? Just forward the wise, even though it's something basic, still important to get it right, because one wrong number can throw off your question. I remember the name of the last person I knew that had white collar is versus blue collar, especially when you're hearing about like political races and whatnot with white collar workers and blue collar workers. Does anybody know the difference? I mean, I can let you guys answer. I don't need to. Say what's a white collar versus a blue collar worker. Or the jumpsuits kind of thing. So blue collar is usually like you're getting your hands dirty, and white collar is usually like you're in a nicer, like an office setting. Usually happens. But the distinction needs to be way more clear as far as like what people would wear. Okay, you guys multiplying? Are you getting money out? You should be, right? Because you're multiplying how much you sold by prices. Okay, let's double check that we have the same one. So you guys hopefully got your matrix A, your 3 by 3, times your matrix B, which is your 3 by 2. What did you guys get for your first one? I think I agree. Do you guys agree with Zoya? What does that stand for? Maybe it's easier to see both of them. And then this one would be 2 of 680. Okay, so we're getting like an accumulation of prices, like how much money came in from the selling price and then how much of that was profits. But aren't we going to have like 3 different columns, or sorry, 3 different rows of that? So it's not the total. To get the total that came in and the total profit, wouldn't we need to add down? So my question is which? How do we label? Yeah, because this is going to be the money that came in from the sales, and that's how much of that was profit. If I would add them all to get the total sales, I would add all those to get the total profits. What are these? Yeah, on Friday, on Saturday, and on Sunday. Where'd the milk go? That was just used, right, for matching everything up. Can't you also kind of tell what the labels would be based on, hey, wasn't it 3, right? 3 days by 2 by prices and profits? So what we get out is the 3 days and the 2 prices and profits. But there's a lot of stuff that we could do with this. We could go ahead and see the total. I you wouldn't want to add across. That wouldn't be very helpful. We could see Friday versus Saturday versus Sunday to figure out the total sales from the weekend, how much would be the total profit. And of course, you have all the data up here as far as all the different things of how many gallons of milk you're selling, etc. And whether or not these prices are effective for whatever you're supposed to be bringing in on the weekends in order to break even for whatever business quotas or objectives that you're aiming for. Anyway, just kind of giving you an idea of how, like in the real world, numbers in this order could be applied. Just one example. And you guys will see another word problem in homework. Let me go ahead and freeze the screen for section 8.3. So some of you guys started taking these notes. Now you see like, oh, hey, inverse. All right, it's a thing. And maybe it'll make sense as to why I'm going to write things up here on the board, like tangent of x is equal to root 3, or square root of x is equal to 4, or 3 ln of x minus 2 is equal to 1. I'm just reminding you of how important inverses have been in the past as far as to meet our goal and our objective of solving for x. But as you guys are writing these down, those of you that have started homework, if you want to grab it out, open it up. I am going to take a couple questions if you have them, because if you got stuck, let's help out you specifically, because you worked hard, you got going on it, and you are stuck someplace. I want to help you out first of all, and then maybe that'll help your class out to be able to keep going tonight when they get there. We're in section 8.2. I'm zooming in. I'm going to start taking pictures just to get them in our notes so we can go through them pretty quickly. Does anybody have anything real fast from homework they want us to look at? Yeah, Emma. Would love to. You go grab it. Somebody have anything else? Just call it out if you do. From section 8.2. Oh, Emma, was it 36 or 37? Oh, got the wrong one. Thanks. Sorry. Anything else out there? Okay. Someone help Nathan out just because we're on a new section. And I noticed that he is completely knocked out. Football's not even in season. Yeah, I know. I see him in trouble. All right, nothing else besides 37? Good morning, bud. We're starting a new section. I had them wake you up. Anything else? All right, number 37, we're going to peek at real fast, and then we'll just keep on going forward. Guys, remember, if there's a homework where you are supposed to start, get started. Then I can go over questions and not have you just be stuck in, like, randomly running to Slater every 2 seconds the night before. You guys know how I feel about Slater. Great resource, not always so hot as far as helping you with your understanding. And, well, let's be honest, the temptation, the struggle is real, and some of you don't even struggle. Yeah, do it. The directions, if I double checked right, I think it was just finding A and B and then stating the order, right? Yeah. Okay. Oops, I came stop. So the nice thing is checking this guy out is totally legal to multiply because those match. My answer is going to be, let me set it up, a 3 by 2. So let's see where it went wrong. I have a negative 2 plus 0. I'm just going to show the work assuming that something just went wrong when you were plugging in. And then we have negative 3 plus 54. We have negative 8 plus 0. We have negative 12 plus 45. We have 0 plus 0. And we have 0 plus 27. I think I did it fast. Is that matching up?
Yeah, I just did some math wrong on the second column.
Okay. That makes sense. I'll finish it off just for those of you that might still be tracking. But yeah, it's easy just with all the numbers to get something a little off. 51, negative 8, 33, 0. And the thing that I found is just like, you guys hear me in class, like I love to try to do the mental math. When I'm talking, when I'm trying to gauge how you guys are doing and getting you guys to participate, like yeah, I get distracted, I make mistakes. But naturally, me and a whiteboard, I would just go for it. or me and a piece of paper, I would just go for it and do it all in my head. But if I find that I'm making mistakes, I just gotta slow myself down. Doesn't mean you have to do the whole annoying like -1 times 2, but just slow it down a little bit. Then you'll probably find it. Okay, that was the one that we had where people got stuck last night, which should be good and encouraging for you guys that some people have gotten into the homework and they're like, nah, it's all right, it's good. No stress. So let's get back into section 8.3. Good time, we just started that section. Did a homework help? Like a word problem, see how many just. Okay, we're going to go fast in the first 3 because they're all reviewed. If you guys remember your cheater chart. We already wrote on the front board how we use tan inverse to get rid of tan, which is very different than division. Or we use square to get rid of a square root, very different than division. Hey, good old-fashioned addition, no big deal. Good old-fashioned division, no big deal. But then, well, life gets a little more interesting. Up here, we end up with x is equal to, any cheater chart people? When is tangent root 3? Not 30. There you go. Square root 3 over 3, 1 square root of 3. It is a 3, but it's a pi over 3, yeah? Or 60 degrees. This one's easy. X is equal to positive or negative? Just a positive. Good. Just a positive. If I square something, anything squared is going to be a positive all the time. So yeah, just positive 16. Well, okay. What's the one thing that I can square and get a negative? We're out in Precalc. Huh? No. Still positive. 0's neither. I mean, you could try him, but he's neither positive nor negative. It's the one thing I can square and get a negative. The imaginary number. All right. Coming back. 1 plus 2 is 3. 3 over 3 is 1. ln of x is equal to 1. Now what? Oh, you can do everything. Yeah, there you go. The whole point was to get to that e. So e to the ln cancels out, and x is equal to e. Okay, that's old school. So now what do we do once we have matrix equations? Well, we realized if you needed the inverse of tangent to solve equations, the inverse of a square root, the inverse of ln, if you need to know the inverse of anything to be able to undo him, it's kind of like an anti-venom to a venom, an antidote to a disease, a vaccine to anyway, all right. If we have any mathematical function, if knowing his inverse is helpful to not only do the function, but to be able to undo the function, same thing with matrices apply. Vectors aren't really like an operation, so we didn't do any inverse vectors because they weren't really a thing. Like vectors are more of a representation of what's occurring and less of like an operation. But matrices, no, inverses are helpful. I don't know why the notes are doing this. Sorry, guys. These aren't meant to be like up in the air, flying around. It's supposed to be an n by n, the good old-fashioned n by n. Let me bring it down. That's really awkward. Sometimes when Smart updates stuff, it messes things up a bit. There we go. Okay, so we have little n by n's. One thing for you guys to realize, and if I were you, I would even highlight it. I would even make a note of it, square matrix. Because guess what? There is no inverse to a non-square matrix. It's a little bit of a bummer, because that means we can never undo a non-square matrix. But that's okay. We can't undo any square matrix. Ooh, we can try to undo any square matrix. That's a little bit harder. For all of these, it's like, oh yeah, you can always undo it. No stress. Matrices are a little bit more finicky, a little bit more particular, a little bit more tricky to work with. But we do know that a times its inverse is I, and its inverse times a is I. Kind of like a square root of a square gets back to x, or a tan inverse of a tan gets back to x. We're undoing a matrix entirely to get back to his original, and his original is the identity. Okay, now that we have that, that didn't work. There we go. How could we, if that's all we know so far, that's it, all we know is that an inverse times his original, or an original times his inverse makes the identity. How could we show, how could we verify, how could we prove that these are inverses? Yeah, just like I heard it in the back and I agree. So A times B, we just need to see, does A times B equal I? If so, then B must be the inverse. So what's negative 1 plus 2? 1. What's 2 minus 2? What's negative 1 plus 1? Negative 1 plus 1. And what's 2 minus 1? Does it work? Yes. But, do you guys see any patterns as to that B versus that A, or that A versus that B? What stayed the same? What changed? All the signs changed? Oh yeah, positive, positive, negative, negative. Okay, I wonder if that's a pattern. I'm not telling you yet, but there is a pattern that will be helpful. I wonder if that was it. Okay, definitions, invertible or non-singular. Invertible, we should recognize this one because that was something about one-to-one functions way back when, passing the horizontal line tests like last semester at the beginning when we were dealing with functions. But I need you to realize that invertible and non-singular go together, and they both mean that, basically, or they both describe matrices with inverses that exist. Maybe I don't know. Do I need to put that exists, matrices with inverses versus matrices that don't have inverses? I don't know. I put that exists because it makes a little bit more sense in my head, but either way. Invertible or non-singular are matrices with inverses that exist. Which is a little awkward because this is a non, it's like a negative word, but it's pointing to like a positive characteristic. It's a little awkward, which means it's going to be a little hard to remember unless you attach something about the meaning and, or the word and the meaning. But think about it. If non-singular means it has an inverse, what does singular mean? Yeah. No possible inverse. Which, think about it, if there's no possible inverse, there's no possible way of undoing it. That could be troublesome. Invertible or non-singular, matrices with inverses that exist. Singular, no possible inverse, aka the matrix can't be undone. Now, if all non-square matrices cannot have an inverse, that also means that all non-square matrices, right, are singular. But not all singular. Don't you guys love like logic writing where it's like, what's going on? Not all singular are non-square. And that's a bummer. If you have a 3 by 2, nope, no inverse. If you have a 5 by 4, nope, no inverse. If you have a 2 by 10, nope, no inverse. If it's not square, no inverse possible. No way of undoing it. So hopefully it's not in an equation or we're in trouble. If you have a non-square matrix or non-square matrices, all of them are going to be singular. No square matrix can have an inverse because inverses go back to identity matrices, and identity matrices are square. Oh, well that's fine. And if they need to be able to multiply both ways. And some of you already pulled out, you can't multiply both ways unless it's a square matrix because the numbers of rows and columns wouldn't match up. It's kind of like me saying all snakes are reptiles, but not all reptiles are snakes. Can I use that one? All bears are mammals, but not all mammals are bears. I just like all the animal ones. Right? We can keep on going, but all Canadians are North Americans, but not all North Americans are Canadians. I just picked on them for a second. But anyway, probably should have picked on us. We're the ones that think like we are. But the long story short is, okay, so all non-square automatically singular, but there are some square that are also singular. In your head, this whole idea of whether or not something can be undone in math is a pretty important idea. So we're going to need today and tomorrow to keep on the lookout, mostly tomorrow for, okay, wait a minute. So non-square are easy to pick out. Yeah, they'll never have inverses. But if there are some square guys, some sneaky square guys that also don't have inverses, how do we know who they are? And we'll talk about that more tomorrow. There is one way to solve for a matrix. I'll leave you guys with this today. One way to solve for an inverse is to say, okay, fine. If I have to multiply a given matrix by another one to get the identity, why don't I just do what I always do in math when I don't know what's there? Why don't I do what I always do in math and multiply or plug in variables for what I don't know? Got something in my throat. Sorry, guys. How do I multiply? Just like we learned yesterday. 1a plus 4c. That's going to be the first one. 1b plus 4d. That's going to be the second one. Negative a minus 3c. That's going to be the third one. And negative b minus 3d. That's going to be the fourth one. Come on, be good math students. If you know that is equal to this, what deduction can you make, or how can you proceed forward? Can't I make a little baby system of equations? Say you have to be 1 and you have to be 0, and oh, by the way, you have to be 0 and you have to be 1. Now all of a sudden, are we in chapter 7 again with systems of equations? Is it possible? Totally. But what's the dilemma? How bad is it for a 2 by 2? Not bad. Think about a 3 by 3, or a 4 by 4, or a 5 by 5. There has to be a better way, right? There has to be a better way. You guys ready for me to show you what the inverse is? You can keep pondering tonight whether or not you can figure out the pattern. What'd I do? Did you see me switch the main? And did you see me opposite the opposite? Wait, does that work for the one that we had just a second ago? If we switch the main and we opposite the opposite? Does it always work? It doesn't always get you to the final answer, but it's always a step in the process. For a 2 by 2, and your brain should be like, oh no, 3 by 3, 4 by 4, 5 by 5. We'll get there. Bye guys, see you later. Going to a nutrition. Start 8.3. Finish 8.2 tonight. There you go. I'll be here 7. I'll be here after school if I can help you on corrections. Please let me know. I am here, but I'm giving tests all day.